Welcome to the Testing Habits podcast. This is Eduard Enoiu. Today I'll be speaking with Markus Borg, principal researcher at CodeScene and associate professor at Lund University. Markus works at the intersection of applied artificial intelligence and software engineering. He is also on the editorial board of Empirical Software Engineering Journal and is a department editor for the IEEE Software magazine. So we'll talk a little bit about software engineering intelligence, AI engineering, ChatGPT, safe AI, requirements engineering for AI, regulations on AI, and many other topics. As you'll hear in this conversation, we cover quite a lot of ground. So without further ado, my conversation with Markus Borg. Thanks, Markus, for being here.
Thank you for inviting me.
I'm so happy to discuss with you about so many interesting things, and it's hard to actually know where to start. Because you're doing interesting research, and you're working in an interesting field. But yeah, for the ones that don't know you, how do you describe what you do and the problems you focus on in your career?
Yeah, I have very broad interests, as you know, we have discussed before, you and me, Eddie, and this can also be seen in my publication. So I am kind of a generalist, and to be honest, this is not always a good thing. Of course, it's a blessing and a curse. You turn into this jack of all trades, and a master of none, perhaps. But I hope I'm a master at some things. But I'm really passionate about software and the engineering behind software. So finding ways to develop better software faster. I mean, these three words, they mean a lot to me. Finding ways to develop high quality software that is, fit for purpose and within the available resource budget. That's what engineering is about. And then software is, of course, such a cool phenomenon. It's unique in several ways, and you never run out of cool aspects to study. But what I do, I mean, if I describe myself as a researcher, I typically say I do quality assurance research. That would be my big umbrella, and that's what I use to cover many interesting aspects such as requirements engineering, processes and practices, certification, and then of course it tends to end up with software testing fairly often, and that fits very well for this pod, right? So my PhD work, it focused on leveraging big data, trying to find all this very valuable data in large-scale software engineering projects, and finding patterns and proposing recommendations accordingly. Training machine learning models has been a big part of that, and that's how I got interested in the whole AI thing. And it actually took quite some time before I felt comfortable with the term AI. I didn't really like it, but now I'm actually fine to call my type of research AI for software engineering, and that's what I do now with CodeScene. And I've also done work on, as you know, software engineering for AI. So the other side of this coin, I largely reversed my perspectives there when I after defending my PhD at Lund University. So I worked way more on how to develop AI systems and how more specifically to do quality assurance and verification validation for machine learning based systems.
Many interesting fields of study there, but you're both working in industry, and I guess you have a foot in academia. What do you have any observations there? Do you think this is especially for the things you're doing research in and you're working with, does it make sense to be both in academia and in industry?
Yes, I think it does, and it really matches my interests very well. I'm really into applied research and trying to bring the good ideas from academia out to industry. My foot in academia is 20%. So I'm an adjunct senior lecturer, and Do teach a bit, but mostly I supervise PhD students at the moment and master thesis students. I've always been very happy in this intersection between industry and academia. I was with RISE Research Institutes of Sweden for 7 years after my PhD, and that is also another type of position that matches my way of doing research very well and making sure we have technology transfer and co-evolution of good ideas together with industry partners. And so yes, it's not always a walk in the park to wear double hats, right? So, I mean, that's sometimes things get a bit messy, and you need to have a good understanding among your collaborators on both sides to make it work. Because suddenly you're swamped with things on the other side, and then you have to take care of that. But I think it's very good for me personally. I get to learn a lot in both worlds. I learn a lot now. I recently joined the private sector again. It has really refreshed my understanding of the contemporary technology stacks and how you develop and deploy and release software in 2023. I was a bit outdated. I worked a few years with ABB before I started doing my PhD research, but this is a field where things change very fast, right? And that's also a part of why it's so interesting to study.
Yeah, I mean, and I guess it's I mean, what would be interesting is to also see what the differences between, working with companies like ABB, which are quite big companies, and the difference on doing software engineering, in small companies or web development. I guess there's a big difference between,
Yes,
the stacks there.
and I'm so happy to see a smaller company now. I've always been in huge organizations, ABB, Lund University, and RISE, and now it's a company with 25, 30 employees. It's so different. I mean, everyone is close by, and you get to interact with so many different roles. It's very refreshing, for sure.
But you mentioned, I mean, couple of things that were interesting. One, that what you were working at you're working in a way in at the intersection of quality assurance, software engineering, software testing, and artificial intelligence, applied artificial intelligence. I'm wondering what made you go on this path. I mean, it's not a straightforward route, I guess, to get here.
No, but it's a very popular topic at the moment, right? It's has been trending the last years. But for me personally, I like stubbornly working with data. I did that during my PhD. Tried to train different machine learning models, and this was before deep learning turned into the mainstream approach of doing things. In general, I think it's such an attractive idea that you have those large scale context, lots of people there, lots of information. It's overwhelming. There is an information overload. It's massively overwhelming for some people. And many of the challenges we have in software engineering nowadays, they originate in this sheer size of the systems. But the machine learning models, I mean, they actually benefit from having large quantities of data around. So that turns into training data. So you can make that data work for you. It's not only your enemy, it's something you can also harness and make it work for you. And that's my story, how I got interested into in AI, I would say.
Mm. And I think this is, I mean, we have seen quite an exponential rise, I think, in popularity of AI, and it's used all over the place, but of course, including software engineering. So, we have engineers now using AI in their daily work. And there, you mentioned already these two aspects, two different aspects of at the intersection of software engineering and artificial intelligence. Software engineering intelligence, so AI for software engineering, and AI engineering, software engineering for AI. And I mean, I know I know some of these aspects and how they work, but I would like to take your I would like to hear your take. Why is it important to separate these emerging fields in software engineering? both from a research point of view, but also from a practical point of view. Um, yeah.
Mm. Um, yeah, I think it's important to distinguish the two terms because they mean different things, right? I mean, it's on one hand you have this you use AI, as you said, as an engineer to help you develop this better software faster. That's one thing, and then the other side is then you evolved engineering practices and processes to develop better AI systems faster. That's another thing, and it's um, uh, just important to clarify that we mean different things here. But of course, you can learn a lot, and there are also conferences and workshops that include both those topics in the programs. But yeah, that would be my answer to that. But it's in general, I mean, it's since I've been working more in the recent years before joining CodeScene with the software engineering for AI, it's a new type of animal we're trying to tame here. I mean, it's the development of a machine learning system. It does require another mindset because the data is there, right? And it's really a first-class citizen, and it's part of the product, and it's you need to evolve your quality assurance,
Mm.
um, and the way you develop your machine learning models. It's also quite different, right? I mean, it's this exploratory work. I mean, if you think agile moves fast, that's really nothing compared to the data science loop where you experiment and experiment and experiment all the time.
Mm.
And then you need configuration management on steroids, basically, because everything matters. There was this Google coined principle, the cake principle, changing anything changes everything. It's very hard to know what comes out on the other side when you train a model because everything is entangled. The data, how you pre-process it, how you um, choose your model architecture and the hyperparameters in the model, and then you have something on the other side, and then you need to test it. And yeah, to support this evolution. Help data scientists emerge at useful models. I mean, we need to develop our engineering methods.
Yeah, but I mean, what I see from my perspective, they work well together. So you cannot have one without the other. So you cannot. It seems to me that you have SE for AI, so the creation of AI software, as an important question, and then you would use this AI, which you developed in a certain way, in software
Mm.
engineering. So it's almost like if you separate this too much, you get to a point where you develop things in a certain way in SE for AI, and when you get on the other side AI for SE, it's a bit you know yeah, they're different. You have different machine learning models, you have maybe different ways to work. Maybe it's good, but I don't know if you have any thoughts on this.
Well, I agree with you that AI for SE and SE for AI are not necessarily disjoint. I mean, the thing is, just like agile today, that was a big research topic in the past, but now it's just part of the context. I mean, everyone claims to be doing agile in one form or the other. And I mean, the AI tools, now we have the whole generative AI boom, right? With the GPT models being everywhere. And my prediction there is that, I mean, give it a year and this will really be widely adopted and be part of the context for large fraction of developers. I use it myself. I think it's way more convenient to check what ChatGPT says about some Python library compared to looking for Stack Overflow answers because I get something that is personalized for what I. So I've used it a lot actually,
Hmm.
and we have engineers here at CodeScene also using it on a daily basis, and not only ChatGPT. There is also like GitHub Copilot and all those things that are AI. We haven't even talked about the definitions of AI, of course, but if
No.
we talk
No.
about machine learning in general, and both, I guess, the generative AI, which is everywhere now, but we also have other types of recommendation systems that are data driven, and for example, what we mainly develop here at CodeScene. I mean, that would also fit into the machine learning
Hmm.
um, arena, I would say. But
we Yeah, I mean, let me maybe one thing I wanted to go like more of a tangent. You mentioned the definitions, or like we didn't talk about the definition of AI, and do you have any preferred definition or one way of seeing this? Because I know there are many many opinions out there, and there it's a jungle that the to look through this terminology.
Mm, it is a jungle. And the funny thing with AI is like trying to define AI has always been like, I mean, people have tried doing this since the 50s. And it's kind of a moving target because what you think is AI, what you thought was AI in the 50s, 60s, that wouldn't be AI today. That would just be standard student assignments in a computer science course and, finding like the shortest path in a graph and things like that. So it's very hard. AI has always been kind of what we cannot really easily do now using conventional methods, something that is a little bit beyond what our current capabilities as developers are. So this is, of course, a problem, but it's super important now when we're, trying to regulate the technology in different ways, and the European Union is, of course, as you know, and probably the listeners also know, spearheading this um, new era of regulated AI. And then you, of
Mm.
course, need to have an AI definition. And the problem is the jungle you mentioned, and different stakeholders develop different definitions. And there was this expert group within the European Commission that came up with one definition. And then in the AI Act that was proposed in 2021, they used another definition. And during the reviewing phase of that AI Act, I was involved in that from the Swedsoft side and from the RISE side on the national level here in Sweden. I mean, the AI definition was criticized a lot because it was just too broad. It was basically anything that was software could also fit under that definition.
Yeah.
And they have now reworked that definition. And I saw just the other week that they've decided to align the European Union definition of AI with the OECD definition of artificial intelligence. And that's, I think, super important that the major players actually look at it in the same way.
Okay, I was not aware of that. So
That's
okay, they
new.
went for
That's new. I saw
that's new. Mm.
that posted with in March, so
Mm.
that's good. But yes, I mean, for me, it has to be something that is then machine learning based, or it has to have some sort of autonomy and some sort of output that is used for predictions or recommendations or decisions, and it needs to influence something physical and virtual. I think this is along the lines of what the new definition is also. It shouldn't be just anything that is using data and using software. That would be too
Mm.
broad. But it's very hard, this problem, of course. But it's very interesting to see how it's being tackled in the European Union now.
Yeah, yeah, I totally agree. And I mean, you mentioned ChatGPT, and I know now I just want to go into that direction because, but you talked about other things that I'm interested in. Maybe we can later on come back to those.
Yeah.
But let's just for a moment focus on ChatGPT and tools like ChatGPT that are now used in real life applications and software engineering, but they have been used for a while. So I know some companies that used this technology before. But many people have pointed out that this seems to be, of course, promising, but also risky technology on our hands. And I'm coming from the side of I like to look first at the concerns and try to get those sorted out first before we all go head in. So, what are your concerns from your side about where this is all headed? Where this kind of AI of this sort is heading in general, and also software engineering?
Yeah, it's important to clarify whether we talk about software engineering or on a society level, right? But let's start with the engineering part, I guess. That's
Yeah,
the focus of
whatever you feel more comfortable. Yeah, of course.
yeah, no, but it's um So I'm not myself worried that the GPT models that are, we just saw them, take the world by storm with ChatGPT, and they will improve a lot very fast. I think we're really at the beginning of something big here. I think it feels sometimes like half of the plants trying to find different ways to use GPT models now. I see workshops on that and webinars and stuff all the time. And of course, at CodeScene, we're also working with GPT models. But I'm not worried that GPT models will make source code analytics as we do here with CodeScene redundant. On the contrary, I mean the amount of source code that will be generated now by humanity or by AI-assisted humanity, it will just grow faster and faster, and the code will not be perfect. It's for us, it's good because it's a generator of technical debt for sure, and the security vulnerabilities and all that. And humans will not be able to review everything. So I think the market for tool vendors will be there for analytics, and then GPT in the hand of reckless users, of course, can be risky and will introduce weaknesses in the software. And it generally lowers the bar for programming, which is good and bad, of course. It's a democracy thing. More people will get the chance to, use the powers of computers, controlling machines in that way. And that's cool. But that means also that less skilled developers will add more code than before. But I don't think we as human programmers will be obsolete. It's sometimes you read about that in news media, of course, but there is such a lack of software developers, and the demand, I believe, will just keep increasing in the next years because digitalization, it drives everything now, and you need to increase the efficiency of the developers we have to meet the needs because it's and of course, I mean, we've seen automation before, and humans will focus on more interesting things and all that, right? But yeah, of course, it's different if you order a pizza on a Friday night or if you, generate code for a flight controller. Of course, I would be more hesitant to enter an airliner with a piece of code generated, right?
Yeah, I mean, I'm thinking that if Microsoft wants to test something on 100 million people, they can go ahead and do that, but they do it without sometimes, I guess, having a clear understanding of the consequences. And maybe it's not their responsibility to do that. But I guess nowadays, when you could take this GPT and use it in a company to, let's say, for example, automate some part of the software engineering process, it seems like we are not yet we are not yet at a point where we have explainable AI, and I think now it's quite hard to assess the reliability and trustworthiness of this kind of tools, and I'm just afraid that we'll just go ahead without actually thinking on how to have a ethical heuristic here. Even in software engineering. And I mean, let's say I can give you an example of test selection. So I mean, if we let this test selection in the hands of an AI, I mean, you could get to a point where if you're developing this kind of safety critical systems, as you said, you will have some responsibility issues. And I'm afraid that we are going into this without actually doing the groundwork. That's my fear. But you can tell me if I'm just being paranoid.
I don't think you're paranoid, and I mean the experimentation on large scale. You mentioned Microsoft; they do that, right? I mean, they had this beta release of Copilot, and a lot of people used it, and now it's available for anyone who wants to use it. And of course, this is an experiment, and I'm sure it has introduced a lot of security vulnerabilities, for example. And then we haven't talked about the legal aspects. We don't really know about what it has been trained on and the copyrights involved, and we'll see some interesting things there. And I guess shit will hit the fan in courts, and we will see. I mean, this in American courts, I believe.
I hope first in American courts. quite
Yeah,
far.
yeah, but yeah, I agree with you that we need to increase research spending on risk awareness here. Of course, I'm all in favor of that, and I think that is also happening. We got just a few weeks ago an application approved for a new PhD student on software testing for AI alignment. So this will be something new and interesting, a very difficult thing to tackle, but it will definitely be a bit more towards the ethical issues you mentioned here. But we hope we can also come up with something solution oriented and pragmatic, especially. We need to take baby steps in the right direction here. We cannot just sit down too much and think about the problem. We need to also propose solutions. And that's our plan for that PhD student.
Yeah, exactly. And I mean, my view is that we should treat it as, as something like drug trials. So you want to know about the cost and benefits, and you want to have a slow release. I mean, we don't want to overregulate, of course, but we don't have anything like regulation around that. So, um, I mean, we're talking now about
Yeah,
what I would call narrow AI, but if we're going like 10 years in the future, and we might have something closer to what some people might call artificial general intelligence, then you will get to the point where it's being a bit worrying. Because I mean, we have the economic incentives here, and they're going to push us somewhere, but I don't think the economic incentives will always push us in the right place, let's say like this.
yeah, and everything is so super application specific all the time when you're dealing with software, and even more so when you're dealing with machine learning and AI, I would say. So I don't entirely agree that it's, the Wild West when it comes to introducing AI. If you, for example, would do test selection based on AI-based tools, I think you would have a hard time to convince your independent safety assessors that this is in line with the certifications they need to follow to be able to release the product. So I think but there is, of course, a gray zone with the semi-critical systems, or whatever you would call it, where you can do things that can spin out of control a bit faster.
Mm.
So it's
Mm.
interesting times. I'm a tech believer in general, so I prefer to be on the positive side here and cheer for it. We haven't
Yeah.
talked about. I mean, we have this entire thing with a moratorium now, right? That has been signed by very many prominent AI researchers and AI. Yeah, I don't know. Many people signed it, and it's
Enthusiasts, let's say like this. You have researchers, you have practitioners, I guess,
yes,
business people.
yes, yes.
Yeah,
A
but
lot of people
maybe
did it. Yes.
yeah, I think so. And I mean, I'm yeah, let's go there then. I mean, should we stop AI progress until we figure out how to do it safely? I know that this sounds very strange. I mean, especially coming from a researcher, and maybe absurd a bit. And I guess my question to you would be: should we wait for its deployment in certain areas until we can do it safely? Um, yeah,
Yeah,
that
that would be the easy answer, I guess, to answer. Yes, in certain areas, you should certainly be very careful, but that's those heavily regulated industries also where, I mean, automotive and avionics and all that. Of course, you need to be super careful there. But I mean, the whole moratorium and the hiatus on AI development, or the stop and all training of deep learning models more than these many layers. I don't know what they have proposed. I mean, it's weird, of course. How could it possibly happen? So I think it's largely a marketing thing to trigger debate, and that's very good. Actually, I like that. I think, to be honest, that probably helped me get funding now for this new PhD student on testing AI alignment. So it's everywhere, right?
yes.
But
AI fear funding research. It's funding
but it's
research.
important.
Yeah.
I mean, we
Yeah.
need to increase fund. I mean, So my short answer to this, should we stop it? No, I mean, what we should do is to increase funding on quality assurance of AI. I mean, of course, that's what I do, so I think that's obviously the thing we should do. But it makes sense. We need to study learn more about the risks, need to learn more about the ethics, of course, as you mentioned, and how to do requirements engineering and process and testing for all of those systems. So I think it's not easy stopping research, right? I mean, how we have tried that a few times. I mean, Sweden was an early role model and prohibited research on nuclear weapons in 1958. I don't know if you knew that, but it's and then we have the UN-sponsored non-proliferation treaty a decade later, and now, I mean, yeah, not all regimes respect and sign those treaties, right? And that's the
No,
problem,
if
right?
exactly. I mean, sometimes if we don't do it, someone else will do it.
And that's
And
my I think that goes also with AI researchers to a large degree. I mean, most serious AI developers think about this, but the sloppy ones don't, and then they wouldn't care so much about the ban anyway. But then we have, of course, capitalism in play also, right? And the market pressure to release things fast. And we see that now after ChatGPT, how all the big players suddenly really push for generative AI models, and unregulated capitalism can lead to very bad effects. I mean, it's not enough just to um, trust the consumers there and for them to make the right choices. So I am a believer in regulated markets, actually. That I should also say. But regulating something as hard to define and such general purpose technology as AI is very hard, and I don't yeah, it's not an easy task, but
no, no.
I think it's super interesting to follow the legislation now, and I think also many steps are taken in the right direction.
Yeah, and I hope people that, yeah, the legislation is made with people that are coming from different parts of the industry and research, because I think we would need the regulation that makes sense for all of us. But the idea, of course, of going to stop the field or even slow it down the progress, it's just unthinkable. And
Yeah, and
yeah,
I mean, I think two different things here. I mean, the kind of research ban or moratorium is one thing, and regulating AI to using it in a reasonable and trustworthy way is another thing, and I'm in
yeah,
that camp.
you're in that camp. Yeah, I mean, and I agree with you. I think yeah, I think we're almost on the same top, on the same side. But you mentioned, yeah, dude, requirements engineering and how important it is to, I guess, to um, you know, when you want to prepare AI for deployment, you need to have at least the requirements for your system in place in a good way. And I read your IEEE software column. Can RE help better prepare industrial AI for commercial scale? I think you wrote this together with a couple of other authors. I don't remember their name now. You will tell them, but I'm
Yeah,
quoting here. Yeah, we you said like something like, we argue that the business side of AI has been underexplored and that requirement engineering can help us go
mm.
forward. Can you expand on this? And why do you think requirement engineering is so important for engineering AI?
Yes. So this was some really interesting work we did together with Siemens Digital Industries, and the authors. You try to remember there. It was Boris Scharinger. He was the first author of the piece, and then Andreas Vogelsang from University of Cologne, and Thomas Olsson, my colleague at Rice back then when we wrote this. And we actually collaborated with Siemens and discussed this for some almost 2 years, and we also did some original research there. We ran workshops and interviews. It was during the COVID pandemic, so everything was online, but very interesting. We didn't really publish the results from the studies, but we learned a lot in that work, and the column is an output of that as well. And the starting point of the column is that Sure, AI is everywhere, and everyone is spending a lot of money, and there are many promises about, really lucrative solutions. And Boris, the first author, he is from industrial AI, then so digital industries, so it's the industry 4.0 and the like. And there haven't been that many success stories from his perspective when it comes to industrial AI. It turns out it's not so easy to profit on it. You can have many proofs of concept, but I mean, really, making money, that's a business challenge. And so it's a little bit different compared to the ethics we discussed about before, but this is more about the commercial side of things and how you can scale it commercially, because you have AI and it's often very specialized, and shouldn't say it's always overtrained, but it's specialized on a certain application, and it's harder than we expected to generalize to other application areas. So and then there are many quality models in the academic literature proposing different dimensions to look at when developing AI. I mean, you have the European Union guidelines. We have IBM has trusted AI a quality model, and yeah, there are several different ones, but there um, is not so much about the business side of things and the commercial scalability of AI solutions. And we think that requirements engineering, I mean, this is provides an overall framework and a big toolbox of techniques you can use when discussing those expectations on machine learning based systems. I mean, when requirements engineering, for me, it's a broad topic. It's not only about really specifying things in a written document. It's really about understanding the needs, and it's not only the explicit needs, it's also the implicit needs of the users. And this is perhaps contradicting what I said before, that, okay, machine learning systems, it's a totally new animal we need to tame. I mean, but yes, but there are also conventional software engineering methods that work and help machine learning engineers today. And many machine learning engineers come from different backgrounds at the moment. It's not so much software engineering, requirements engineering training necessarily in those new data science programs. And so it's also a reminder for that new generation of data scientists that we have good ways to sit down and discuss and do trade-off analysis, for example. That's a very concrete thing, and that's something you need all the time when developing a machine learning based system, because there are so many trade-offs always. Stakeholder analysis, trying to I mean, there are structured ways to systematize this work.
Yeah, I think this is a really cool piece of work, and I think there needs to be done. I mean, people should do more, not only research on this, but when you try to prepare industrial AI for the commercial scale, I think you have this kind of perspective that are important. But one thing that I really enjoyed while reading the article was there were some pitfalls, I think you call them, like pitfalls, like specific machine learning project pitfalls, and what opportunities for requirements engineering you can have. And the under specification challenge was very interesting, because I think we see this all over the place, but I see this as a problem in especially in AI, under specifications, the gap between the requirements that you have in mind when you build something and the requirements that are actually enforced. Yeah, I think that's something that
and when we're talking about general AI now, I mean, entering the picture, I mean, how would you even begin to tackle that challenge? I mean, that's already hard for the narrow types of AI. But I mean, I think we're not very close to general AI, to be honest. I mean, it's but yes, this is an important challenge, and it's actually also a challenge in general software engineering projects. But I mean, when AI enters, I mean, then it's
But that's the thing. We look at ChatGPT. I mean, you wouldn't consider that maybe general intelligence, but ChatGPT
it's the closest we have,
interesting.
for sure.
Exactly, because it's not as narrow in some way as most traditional narrow AI,
No.
and yet it's not really general AI either. It does not perfectly fit into the category as I would say it. But so a typical narrow AI would be, I don't know, it will play chess, play Go, and for me it's important, like from a software engineering point of view. Let's say the use of AI for software engineering in software engineering. You have many of these approaches that are AI, machine learning oriented, and I think it's interesting that these are not concerned with, grounding this into some type of, high level cognitive theory, of human mind, doing software engineering or a human based testing. I mean, you wouldn't consider AlphaGo as a theory of human Go. You will not use it like that. But it shows that, when you have automated system that can beat humans, or, try to be as smart as maybe in some way as humans, we argue. I mean, I argue that we have something to gain from, modeling human cognition and mimicking this in our tools, and in the future get something closer to what I would call general artificial intelligence.
Mm.
But I don't know if you have any any thoughts on this.
Yeah, it's
Yeah. Oh.
Go. I think it's. I mean, it's very interesting. I mean, what you also touch upon there is, I mean, the power of combining human and machine intelligence. I mean, that's for sure something that has revolutionized Go. I mean, you learn new tricks from the AI, and you kind of model what they did from a human perspective, and then you found new strategies for how to play Go, and that's a little bit along those lines of what you said about the modeling, I think. And I think we'll see so much more about that. I'm surprised. One example I have that I'm surprised we haven't seen more of is like AI generated music. How hard can it be to generate personalized hits that just tickles your specific brain in the ways you really likes music to be, right? And maybe if you don't like it, you will learn, musicians will learn new tricks about how to,
Mm.
play music, and that can be then used to come up with new human or made music as well. So I think we'll see a lot of that actually. It's computational creativity is a really, really cool field, I think, and combinatorial creativity as well. So this I'm looking forward to the future.
I mean, yeah, I haven't checked this field of, music generated by AI and see how this goes.
Neither
But
have I, but I know that Spotify is worried about it, of course. For example, that's nearby here. So
I
I
can
mean, it's
understand. I can understand why.
mm.
But I mean, it's interesting to me. Like anybody who's played with, let's say, I'll take this example because a lot of people played with ChatGPT, and they realize it does many things. Maybe not super well, but it's almost like it's um, a jack of all trades. It does a lot of things, but it is not a master of those concepts. It almost feels like when you get an answer that you have to improve it somehow. It's so you so it's almost like you can talk it about chess and it will play okay chess for a little while, but probably eventually it will just not, because it doesn't understand the rules of chess,
Mm.
it will have problems. So I'm taking this example. So for me, it's obviously when we talk about artificial general intelligence, I'm expecting something that's more trustworthy and reliable than what you would have now in the case of ChatGPT. So
Yeah, I
um,
agree. And for sure more transparent about when it is just making crazy guesses and hallucinating things, right?
yeah,
But
exactly. Yeah. But I guess that you discover this and then you fix them and you go
yeah,
forward,
but
I
I
guess.
have a on the contrary, I would say that sometimes it's the opposite also. I mean, you have now an example where you like push it and then you reach its limits and you see that I had to improve on the answer it gave me. But sometimes, I mean, what is it really good at? It's really good at natural language. So what I use it for also is, I write something and then I tell ChatGPT to revise it. Can you revise this for clarity and reduce it to 80% of the words or something like that? And then it's a master, and then it does it better than I do it. So that's a bit scary also, because I'm a trained technical writer, and sometimes but it's of course something you want to do in tandem. It's a new tool. I mean, we had spell checkers, then we had Grammarly and the like, and now we have this type of revision support. So I think it's natural evolution.
Yeah, yeah. I know. And I think it's in I'm yeah. I think this is very, very convincing, and I really like this way forward, but I have the impression that we created a technology that makes the cost of producing nonsense and nonsense that passes for knowledge almost go to zero. I mean, it's basically like that. I mean, I'm I'm at that point that people actually think that this is AI, and I'm in a way, for me it's like, maybe it's not the AI that I was thinking of. That's what
Yeah.
I'm.
And now we're reaching the societal level of the question you answered before about where
Yeah,
we're heading with all this, of course. And that's very interesting to discuss, and we don't really know, but we're for sure going to face issues. I mean, the world spins very fast, and a substantial part of the population will be tricked by this. And of course, we've had scam, like Nigerian prince scam emails in the past. We've had that for decades, right? But now you will soon, I believe, receive, those personal deepfake emails with video chats of your grandchildren desperately asking for money, in a bad situation somewhere. And people will transfer money, of course, and that will be very, very hard to assess the provenance of such. I mean, my parents would of course be tricked by that. So I mean, it's
but
critical thinking has never been as important as today to teach, and it will become even more important. So I don't.
exactly.
Yeah.
But I would say that the same thing about, let's say, the use of AI in safety critical systems. So you could use this to fool the assessor very, very easily.
Mm-hmm.
So now the question is, what, it's like, how can we prepare for an AI future where organizations are using AI, and then they use it in a certain way where the assessor might have even problems comprehending how they did things. I think this puts a lot of pressure on the assessor. Let's say I just give
Uh-huh.
so you
Okay.
need critical thinking. You need an AI with an assessor with critical thinking. It needs to be educated on how to spot the potential
Yeah,
problems.
I think the
Yeah, I don't know.
assessors could be trained. That's they're not as many as the general public, right? So it's probably possible to train the assessors and provide them with the tools that really can be used to assess provenance in different ways. But it's also a part of engineering ethics, of course. I mean, we need to teach that also. We've had scandals before. I mean, we had Dieselgate and all that. I mean, you can
Mm,
trick assessors.
of course.
There are ways
Yeah.
to do that, but it's of course if you have more powerful tools, yeah, the
Mm,
assessors will need more powerful tools too. But in general, I believe most engineers are working in ethically motivated ways. But and
mm.
if they don't, I mean, it's a lot of trustworthiness at play
Yeah.
at risk also. So, but yeah, I,
I'm saying that in my mind, all these problems that you mention at the society level, I see them also at the
mhm.
company level.
Okay, yeah,
And you could, for me, I'm thinking of a future where you could imagine a system that would compute the consequences, sort of like, Asimov's law approach. You take this, I take this as an extreme, but the whole idea is like, can we actually compute the consequences to a company, society? Well, that society level it would be harder, but I think there are places where you can compute these consequences. And yeah, I think this would be an interesting way to build something that it has an ability to compute consequences and represent certain values and reason over them. You know what I mean. So it's like, for example, in the case where the ChatGPT is making stuff up. I mean,
mm.
I would expect the engineers to have figured this out before they actually did it, because I am thinking that I mean, we should have this value included in AI,
Mm.
um, to start with.
Mm.
Um, it's just common sense for any type of yeah. I don't know. Maybe
This is
I'm
interesting. You made me think in new ways here. I haven't thought about this with tricking assessors on the software engineering context as much as before, but I mean, you're right, of course. I mean, if the assessor asks for a review protocol, I mean, you could just generate it on the fly and get a perfect review protocol, or a process describing how you do test selection or something like that. I mean, a GPT model could just provide it in real time when the assessor asks for it.
yeah,
Yeah. Oh, wow.
yeah.
Yeah.
I
Cool.
think it
I
very
didn't think
cool.
about that.
Yeah, good. I'm
Scary.
I'm happy to generate hypotheses here and things that can be researched by people. Actually, I'm looking forward to people hearing this, doing the research, and I can read it because I don't know if I want to do it myself.
Mm.
But yeah, so I think we discussed quite a lot about so many things. I actually, but I wanted just to get your thoughts on a project that you're running. I think until 2022, if I'm not wrong, on
Yeah.
safety analysis and verification and validation of safety critical automotive systems, and these are systems that embed machine learning components. If I'm right, so this seems like an interesting endeavor and very much related to what we talked before.
Of course,
And
yes.
I'm wondering, what are the main takeaways of your research in this area? I mean, can you really safely engineer deep learning for such applications?
Yeah, well, the main takeaway there would be yes, you can do it, right? I mean, it's also but it involves a lot of work. You can have safe machine learning. I'm convinced that you can have that, but there are a few things to set straight then to make sure the listeners are following here. I mean, first, what is safety in this context, the automotive context? I mean, it's a negative system aspect actually. I mean, it's about something that isn't there. So when dealing with a safety certification of an automotive system, I mean, you talk about the absence of unacceptable risk. And that, of course, opens up for interpretation, argumentation, what is acceptable and what are the risks and all that. And then you do this argumentation and you collect it in a safety case, which is this structured argument backed by evidence, not generated by GPT models, real evidence, hopefully. And this is what the independent assessors then scrutinize before you get the certification. So this is what we mean by safety. And then when we worked in our Smile project, this has been ongoing for a while, this project. So we worked with ADAS, so the advanced driver assistance systems. So it's really on the lower end of automation levels. There is a human there. Someone is behind the wheel, operating the vehicle and responsible for operating the vehicle. So we're not talking about full autonomy. We have a driver. So an easy way to develop a safe system here, an ADAS system that can intervene, is a system that never does that. It never intervenes, and then it's safe because but then it's not very useful. Of course, it doesn't add any value whatsoever if it never does anything. So we worked on emergency braking systems, pedestrian emergency braking systems, and then we worked with machine learning models that are trained once and then deployed in the vehicle. They didn't learn along during operations. This is also very important to mention. So just to so a lot of caveats here and a lot of restrictions, limitations, but this were the type of systems we worked with. And but already with those simplifying conditions, I mean, it needs a lot of work and you need to think about what can happen. So you have false negatives, failing to brake when there is a pedestrian, right? And since it's an assistance system, there is a driver paying attention. I mean, that's how it should be used, and the human driver is responsible. So that's not the issue because that's controllable by the driver. But it's the other way around. I mean, it's a false positives when you just suddenly hit the brakes and the driver has no controllability at all. It's an emergency braking system, so it's just full stop, right? And then you have dangerous possibly hazards then. I mean, you could have rear end collisions. It's sometimes called braking for ghosts. I mean, maybe there was a plastic bag or something, some reflection that made your vision system detect a false positive, and then yeah, this is a real hazard that needs to be tackled by safety engineering. So we worked on a safety mechanism there to a neural network supervisor that rejects the input if it's highly uncertain, if it doesn't at all resemble what you had in the training data. And then, of course, we talked about requirements engineering before. We had requirements engineering strictly in place, and then we tested and tested and tested and showed how how we reached our targets. So that was a lot of fun in that project. And we followed. Yeah, sure.
No. Go ahead, please.
I just want to give some credits to the kind of overall framework we worked with. So I mean, it was an emerging or a new standard. Actually, it turned into a standard last summer. SOTIF, the safety of the intended functionality for the automotive sector. It complements the previously existing functional safety one, ISO 26262 that everyone knows in the automotive industry. And then we developed a safety case by following AMLAS. So it's a framework from the University of York in the UK. They have been working on safety for decades. It's called the Assurance of Machine Learning for Use in Autonomous Systems, AMLAS. And it really helped us to structure our safety case. So we're very happy about the work they did there. Yeah, and it's has been publicly released now, this demonstrator, and the safety case has been published in Software Quality Journal. So we're very happy for that. It's publicly available and open for anyone to scrutinize. And hopefully we can build on it also in the future.
I think this is really interesting, and that's why I also brought it up, and I was really curious about it. And I think it's interesting when you talk about deep learning systems. They're heavy, I guess, on big data, and on using some particular techniques. But they, I guess, I mean, I'm not a deep learning expert, but they have a pretty superficial representation of the problem. That's why you would, when you use deep learning in this cases, because you can be, I guess, in this narrow AI, I think you can be confident of. So even if a system that navigates turn to turn, there is a problem, like, I don't know, the map would be out of date. There's a, I don't know, a broken bridge, or you can, I mean, but still you can trust the algorithm. But we still don't really know how they work, and I mean, we kind of do. So I think for me, it's still, I mean, I'm coming from the formal verification also side, where I like to formally verify algorithms.
Then you'll have a hard time in this space.
Yeah, I know, but still, I like to come with that mindset where it's this paradigm seems to me, problematic from a verification point of view.
Yes, but there are also researchers trying to do that, right? Trying to scale up the formal verification methods. So I mean,
there is some work there, but there are some problems there.
Yes.
I think it's very interesting to talk with you about this, and I could talk about with you like hours, and maybe we should do a second episode maybe. But I just want to ask you like 3 last questions, and I usually ask them to everyone I talk with. And one is what is the one common myth you want to debunk about software engineering? And it could be software testing, quality assurance.
Yes. So I would debunk something that scared me a bit when I was a student. So I think it's something I would have needed to hear back then. So I was afraid of all the super advanced algorithms in all the textbooks. I mean, I feared the future. I mean, where I, as a software engineer in industry, would have to come up with all those super smart solutions in the computer science textbooks. And complicated programming language constructs used in ingenious ways. And, I had this feeling that source code in industrial settings, it must be super difficult to comprehend, right? And this is a myth I would like to debunk then. I mean, if the code you encounter in industry involves super complex functions, then someone does something wrong, probably. I mean, that would be then an example of technical debt, something that should be refactored and simplified. So it's not about the very hard algorithms you need to implement. You need to implement simple solutions and reduce complexity as much as you can. And simpler the better. It's not like you're going to implement advanced data structures like red black trees and whatnot. There are standard libraries nowadays. That's not the kind of complexity you should fear as a student. It's the complexity comes from the scale of having many people and having many components working in interconnected ways. And it's hard to overview what is going on. But on the file level and the function level, it shouldn't be that complicated and hard to understand. Right? It's opposite. So that was a myth. I was, as I said, I would have needed to hear this when I was a student.
I totally agree. I think that's a good myth to debunk. While you're there in industry, you can start there somehow. Yeah, but I mean, and maybe this is related. I guess this is related to the next question. But maybe there is an advice that you have for students getting started in software engineering, AI engineering today.
Yeah. Yeah, again, the student perspective then. I mean, it's congratulations for choosing such an interesting field. I mean, that's cool. You're in for a ride. Software engineering, it reinvents itself all the time. So keep curious. I mean, it's you need to keep stay on top of what is happening. I have two pieces of advice for that. Then I mean, it's maybe for some of you it works, for some of you it wouldn't. But I mean, for me, it has always been good to have some kind of pet project, something I care very much about. Maybe something that is connected to a hobby I'm passionate about, or some pain point in everyday life I hate to do, and something that I can kind of keep evolving over time. And if you do that, if you have something that you really like, it's a good chance that also others will like it. So open source it and take care of it. And as you learn things in new courses, as you learn about testing, you can try your test techniques on this project and take care of it like you would take care of your garden and make it your display window of your skills. I think it's really good to have something like that in the CV. I would look for it definitely if I was recruiting someone. And then, I mean, the second one is about this crazy speed of everything. I mean, you need to find good ways to learn, develop your learning skills early. And this is individual. These are different. We have different ways of learning. But I mean, you need to go beyond the course descriptions and the textbooks. You need to find ways to learn, complement the textbooks by, learning from YouTube and blogs and all that. But people do that already, I think. But that's why I also want to say complement here. So don't skip reading the textbooks. That's actually a piece of advice I have as well. I mean, as an instructor, I carefully select a good book for the students among the many available, and the authors spend a lot of time collecting information, writing books. So the books are also good. But I love physical books. I mean, it's there are differences
I
there.
do the same.
Yeah, I
have
see
a
your
lot of
bookshelf
books.
in the picture there, right? It's
No, this is just a part. But yeah, I think this is good advice also for course responsibles. I'm just saying, yeah, to make sure that this is, done in a good way. Yeah, so maybe the last question would be, where can people find your work and how can they get in touch with you? I mean, just to, yeah.
Yeah, I do have a website, a personal website. It will be markusborg.com, so my name without vowels.com. And then I'm available on email, markus.borg@codescene.com for sure. I'm on Twitter. And yeah, please reach out if you have any thoughts or questions.
Good, but yeah, I will leave I will leave I will write the website and the Twitter handle and in the notes so people can reach your website, and I guess from there they can look for some of the aspects we talked today and some of the projects we mentioned.
Yeah, indeed.
Yeah, but now I think, thank you, Marcus. This was a pleasure. I'm getting inspired now just by talking with you, have like for an hour. And I really appreciate you doing this.
Yeah, thanks for inviting me to the podcast.